Welcome to all. So in this lecture we are going to discuss combinational circuit design, how to design a combinational circuits. Okay. So basically digital circuit is classified into two types. One is combinational circuit, another one is sequential circuits. Let me briefly explain about combinational circuits. So it depends upon only present input of the circuits. That is, currently I am giving one input is take an example of AND gate. This is input and this is output. So right. So these two are inputs AB. This is AB input and this is C output. So now this AND gate is depends upon only this AB. So presently if I am giving 0 1 means it will produce one output 1 or 0. When I am going to change 1 0, again it is going to change the output as 1 or 0. So the circuit is depends upon only present input, not depends upon the past output. This is what combinational circuits. So it depends upon only present input. Okay. So with this we will enter into the topic. So combinational circuit. Combine the different gates in the circuits. For example, encoder, decoder, mux, demux. These are all the applications of some of the types of combinational circuits. Okay. So the output of combinational circuit at any instant of time depends only on the levels of present at input terminal. This is very important. This is the definition of combinational circuit. So which do not use any memory. So memory means to remember anything we are in need of some memory power. So here depends only present input. So it won't bother about the past output, past input or past output. So there is no need of memory. Okay. And it is have an n number of inputs and m number of outputs. Yes, any number of input and any number of outputs. So this is the block diagram of combinational circuits. These are all the input and these are all the outputs. Right. And some design procedures will be there. How to design a circuit. So the first one is understand the given statement. So the statement is design a combinational circuit of which is going to produce output 1 for these kind of combinations. So first we need to understand the problem statement. Okay, once you have been identified the concept, then construct truth table. That is the second step. Construction of truth table is the second step. The third one is using Boolean simplification, that is K-map or Boolean simplification. We are going to find the Boolean expression. That is what our third step. And fourth one is we are going to draw the logical diagram. Okay. So this is a combinational circuit design procedure. Okay. So first understand the concept, then construct the truth table, then derive the expression and draw the logical diagram. First we are going to design adder circuits. There are two types of adder circuits there. One is half adder, another one is full adder. What is the difference between these two, half adder and full adder? Means here two variables only used, here three variables only used. But both are going to perform addition operation. Number of inputs is different. Okay. Right. Half adder design. So in half adder design, first so half adder is a combinational logic circuit with two inputs and two outputs. So any kind of order, there are two outputs possible. So one is sum, another one is carry. Okay, so two inputs and two outputs. The half adder circuit is designed to add two single bit binary number A and B. Yes, A, B are inputs. It is the basic building block for addition of two single bit numbers. Yes. And it has two outputs, carry and sum. And this is the block diagram for half adder. Two inputs AB and sum is output and carry is output. Sum is represented as S, carry is represented as C. And this is the truth table. Two inputs AB. Okay, four possible combinations 0 0 0 1 1 0 1 1. And outputs sum and carry, so S and C. Okay, let me explain how to add these two values. So first combination AB values are 0 0. So while adding 0 plus 0, the result is 0 and there is no carry is generated. So sum is 0 and carry is 0. then 0 1. Add these two values 0 1, 0 plus 1 which is equal to 1, and there is no carry, carry is 0. So sum is 1 and carry is 0. And 1 0, 1 plus 0, sum is 1 and carry is 0. Then 1 plus 1, 1 plus 1, 1 plus 1 which is equal to 0, sum is 0 and carry 1 will come. Okay, when we are adding two ones, the result is 0 and carry 1 will come. Okay, so carry is 1 now and sum is 0 now. Okay, so this is the truth table construction. Next we are going to find the expression for S and C. This is C, output is S and C. So for this S we are going to find the expression, and for this C also we are going to find the expression using K-map simplification method. So for K-map simplification method we have been discussed three types of K-map simplification: 2 variable, 3 variable, 4 variable. So our first job is to identify how many variable of K-map is needed. So for that, let's have a look at these inputs. We are having two inputs. So the number of variable K-map is which is equal to number of input. So two input is there, so we are in need of two variable K-map. Okay. Have a look at this. Two variable K-map drawn with the 4 boxes, and this side I have written A and this side I have written B, and 0 1 is marked, and this is also 0 1, and this side 0 1 and 0 1. In the respective places we are going to fill the values. See, this combination value is 1 now. So what is the combination? 0 1 now. So where is sum? Here it is sum. So 0 1, so this place value is 1 is written, and here 1 0, so 1 0, so this place 1 is written. So here I think there is no possibility to make a quad, because all 4 boxes are not filled completely. So quad is not possible, leave it. Then possibility for pair, not our adjacent cells are filled, so pair is also not possible. So we are going to consider this is a single term and this is a single term. So for this single term, while writing the expression, A value is 0 and B value is 1, so A bar B. And here A value is 1, B value is 0, so A B bar, which is equal to A exclusive R of B. This is for sum. Okay. And for carry, for 1 1 combination the value is 1. So 1 1 combination, so here value is 1, only 1, so there is no possibility for quads and pairs. So left side A value is 1 and here B value is 1, so carry is AB. So I hope you guys are familiar with the K-map, because in the previous lecture itself we have clearly discussed how to use K-map. Okay, right. And this is the logical diagram, how to draw the logical diagram. So A XOR B. Okay, so let us take let me erase. Right. So A, B are two inputs. So I'm going to take A and B are two inputs. Okay, then draw one line from A and draw one line from B. So what is some expression? A XOR B. We know the gate symbol for exclusive OR. So I'm going to draw first one first one XOR gate here. For this XOR gate, what are the inputs? One is from A. Let's draw the line from here A. Another one is from B. Then draw the line from here B. And this is what sum. And carry is what? AB. So AB is in a product term, so we are in need of one AND gate. So here I'm going to draw one AND gate, and the inputs are from A as well as from B, and this is carry. Have a look at this. These two are correct, no? Yes. In this way only we are going to draw the logical diagram. So for this half order design, I hope you guys are understand. Two inputs are needed, two outputs are needed. So let's draw the block diagram with two inputs, two outputs, and construct the truth table using addition operation, and find the expression for the output using K-map simplification method, and draw the logical diagram. Okay, this is what the half order design. Next, full adder. So full adder is developed to overcome the drawback of a half order circuit. That is, if the number of variables increases from more than 2, what we have. So full adder. So it can add two 1-bit numbers A and B and carry in C. Okay. So it is a 3 input and 2 output combination. So 3 input, 2 output combination circuit. And have a look at the block diagram. So 3 input A, B, C and 2 output sum and carry. And to table 3 inputs. So 2 power 3. How much? 8 possible combinations. 2 power 3. 8 possible combinations. So 000 to 111. Then outputs. So let me explain how to add these 3 values. So let us take this example 0 1 1. So 0 1 1. So when we are adding even number of ones, the sum is 0. Okay, so 1 plus 1 0 and carry 1 will come. So see, for this condition sum is 0, carry is 1. Let me go to this last condition 1 1 1. First add these two, 0 will come, result 0 will come, carry 1 will come. So first write that carry. Okay, then this 0 plus this 1, sum is 1. So 1 1 is the result for the last combination. Okay, let me go to the K-map. So for sum, how many places are filled? 1, 2, 3, 4 places the sum values are filled. So here 4 boxes are filled. Okay. Similarly for carry 1, 2, 3, 4 boxes are filled. Sorry, here this is sum. Okay. Right. So in some expressions we filled, but there is no possible to make a octet, quad, pair. Only single only possible. Okay. So each and every boxes we need to write the expressions, and we need to do some Boolean simplifications here. Finally we will get the expression as A XOR B XOR C. This expression will come. Okay. And similarly for C out, see first these two we can make it as one pair. Here one single one is there, here one single one is there. For this one we can use this already covered one as a pair. So these two are one. And for this one again we can use this one. So these two are one. Okay, so here 3 pairs are there. Let's write the expression from the table. We can get the expression like this. Okay, then logical diagram. Yes. So now we are having expressions and we know how to draw the logical diagram. Okay, right. So half order and full order design is over. Then we'll move to the subtractor. There are 2 types of subtractor is there. One is half subtractor, another one is full subtractor. So again here 2 input is used, again here 3 input is used. That's the difference. And 2 individual produce 2 outputs. Those outputs are difference and borrow. In addition, sum and carry will come. In subtraction, difference and borrow will come. Okay. Right. Half subtractor. It's a combinational circuit with 2 inputs and 2 outputs, and the outputs are different and borrow. Okay. Let me explain. So this is the truth table of half subtractor. A and B are 2 inputs, A minus B. So first combination 0 minus 0, 0 minus 0, the result is 0 1. There is no difference. Okay. Then 0 1 combination. This is very important. 0 minus 1, whether we can be able to subtract? No, we can't be able to subtract. So I'm going to get 1 from the neighbor portion as a borrow. So now this portion becomes 1 0. 1 0 value is what in normal decimal representation, which is equal to 2. So this 2 minus this 1, answer is 1. 2 minus 1, answer is 1. Already borrow 1 is there. So answer is borrow is 1, difference is 1. So see, difference is 1, borrow is 1. Then 1 0, 1 minus 0, yes, we can easily subtract. Answer is 1 and borrow is 0. So 1 0. And 1 1, both are 0 0. Okay? Yes. Then K-map. For difference and borrow, we need to draw the K-map also. So fill the values. Here there is no possibility for pairer. So we are getting the result as A XOR B. And here for this is A bar and this is B. So A bar B. Okay. Next we are going to draw the logical diagram. This is the logical diagram of half subtractor. So this making of this truth table is very important. Once truth table is clear, then we can automatically draw the rest of the K map as well as logical